Hello, my name is Varun Bhatt, and today I'll be talking about how I created a playable summary level from a collection of Super Mario levels for my master's thesis. My advisors were Professor Gillian Smith and Professor Mark Claypool. My two readers were Professor Jennifer DeWinter and Professor Charles Roberts. I'd like to thank all of them, as well as my well-wishers for their continued support. Before we start, what is a summary? A summary is usually an abridged version of a source content that highlights the main points within the said source. So for example, a book summary could describe the major plot lines and contain the characters of the book. An audio summary could be a short clip of samples from a longer audio file. Similarly, a video or a movie summary can be its plot, a montage of events, or a narrative summary. Sometimes it can be all three. So, what is the summary of a video game? This is a question that has been asked by many and has some interesting answers. Being multimedia, a video game can have summaries in the form of narratives, monologues, and montages, and sometimes it can be all of them together. In order to create this playable summary, we first needed to choose our source game. Once we had it, we needed to obtain the salient or important regions within that game to include into our summary. In order to do this, we asked users like you to play parts of the original game and to mark the regions that felt important. Once we had these regions, we analyzed them and aggregated them to be included into our chosen generator to generate our summary levels. We then curate and select two candidate summary levels for our final study. Here, we ask users to play the same parts of the original game as the previous study before playing our two summary levels. Later, we ask users which of the two levels was the better summary. We also use the data to contrast the play experience of the original game to the play experience of the summary levels. We selected Super Mario Bros. As our game of choice due to its popularity, its linear nature of play, and the availability of frameworks and generators. However, the original game has 8 worlds, wherein each world has 4 levels. Creating a playable summary of all the levels would be a Herculean task and out of the scope for this thesis. Therefore, we select 3 levels to be summarized into our summary level. These levels are 1-1, 2-1, and 4-1. We use the Occupancy Regulated Extension generator to generate our summary levels. Furthermore, our user studies are conducted using the Mario AI framework. In order to identify the important points of the 3 levels of Super Mario, we first ask users to play through these 3 levels under observation by a researcher. Then the users mark and identify regions that they thought were memorable. Furthermore, the researcher also marks and identifies regions that they thought were memorable to the user. Here, memorability means areas or objects that the users found to be memorable after the gameplay session, regardless of the emotion associated with that game element. For example, a user could associate defeat with a Goomba and yet have it be memorable. Similarly, the researcher could associate a different emotion with the Goomba based on user reactions and mark it memorable. We use both perspectives to better flesh out our salient regions. Both users and researchers identified these regions on paper using physical level maps that were divided into 1 by 1 cells. Each cell represented a pixel area within the original game. We transposed these cells onto Excel sheets and gave each marked cell the value of 1. Once we did this for all level maps, we added these cells together to generate a heat map of salient regions for each of the 3 levels. We then extracted our salient region of cells and filtered them according to the salient score, which we obtained from the addition of the salient regions. The salient score tells us how many people thought a cell or a group of cells to be important for that level. We grouped these cells together according to an ascending difference in salient scores. For example, if the first cell grouping consists of cells with a score of 16, then the second cell grouping consists of cells with the scores from 15 to 16. This is done in order to maintain a contextual relation between cells with the rest of the level. These cell groups are inserted into the Occupancy Regulated Extension generator, which generates the summary levels. We generated 20 summary levels for the purpose of this thesis. After some analysis, we selected 2 candidate levels for a comparative study. The final summary levels were filtered on metrics of difficulty and mechanical complexity. In the user study involving the summary levels, we've asked participants to first play through the 3 original Super Mario levels. Following this, we asked them to fill a survey that gauged their play experience by having them identify adjectives of play. Then we asked them to play our 2 summary levels, following which they were given a survey. This survey asked the users to identify the adjectives of play for the summary level's play experience. Furthermore, it asked them to tell us as to which level they felt was the better summary. We then compared the adjectives of play to find out if the play experience of the summary levels matched with the play experience of the original levels. Our analysis netted some interesting results. Out of the 5 participants, all 5 reported similar adjectives of play in both play experiences. However, one participant reported that the summary level experience was artificial or odd, while several participants reported both experiences as okay. All 5 participants reported the same summary level to be the better summary. Through this thesis, we find that it is possible to automatically create a summary that provides a similar experience of play as the original game content. Furthermore, due to the context-independent nature of Occupancy Regulated Extension generator, this methodology can be followed for a different game that has similar principles of level design as Super Mario. Despite the collected data, we cannot say with certainty if the summary levels we created summarize the 3 original levels or not. For this to happen, we would need further testing as well as a larger and more diverse participant pool. However, this thesis does provide an important stepping stone towards identifying salient regions of some Super Mario levels through user-identified patterns of memorability. A similar study using different metrics of identification such as difficulty, satisfaction, or enjoyment would net interesting results. Overall, the potential and application of this work are numerous depending on the hands that use it. Thank you.